Hello, this is Brian Cooper, and this is Module 5, Part 2, Rich STEM Screencast. And my project's called a light up map. So, activity summary. In groups of 3 to 4, use the engineering design process to design and build a light up map that is scaled down and proportional of the X floor of our school building using paper circuit components. The activity would follow a lesson where students explore using paper circuits and the different possibilities that are available for them, in addition to learning about proportion, scale, and ratios used in map making. So we are going to use the students and I, while doing this, are using the engineering design process in order to execute the final product. So what is the problem? The problem that I came up with for this was new students and staff are having difficulty navigating our school building and are getting lost. So imagine, I thought a possible solution would be to create a light up map of each floor that is scaled down to the size of a standard sheet of paper to be hung up at various locations. Plan. Students would have to figure out that they would have to measure the interior walls of the floor of the building they are assigned and use their knowledge of scale, ratio, and proportions to create an accurate map. Students will have to use their understanding of setting up parallel circuits to have the designated points on the map light up. Now we go into create. So since I was not actually in my building in order to actually take measurements, students would have to take measurements and use their knowledge of scale, proportion, and ratios to figure out how to accurately measure and scale down a map. So what I did was I first measured about 12 centimeters, and I made that my one side of the wall. And then using my best memory, I created a diagram of the building of at least my fourth floor. And then I needed to transfer my outline to a solid sheet of paper. And on that loose leaf, I what I did was I created a circuit board so that it would connect, and using my knowledge from going through the paper circuits activity book that came with the circuits. So here it is. This is the back layer of the map, and then the front layer of the map would show all the designated areas. And you can see here we have the stairwell, the library, the biology lab, the chemistry lab, the physics lab, the robotics room, and another stairwell. And this is a map of the fourth floor that lights up. So you can see that this back layer has the circuits on it that is being concealed from the front map that does not show that. So improvements. So a way we can improve it is, instead of using flimsy loose leaf paper, I could have used cardstock that is sturdier. And maybe I could find a computer software program that could have been used to help make the dimensions of the map easier. So here's my design tool 5.1 STEM lesson specification checklist. Is it an engineering challenge? Yes. Students can relate. Everyone relates to getting lost. There are multiple and acceptable creative approaches. My approach was just one approach. I could imagine students could use different approaches, maybe using graph paper as a helper. It is science and math grade level content. It does use the engineering design process, student-centered. Students are doing the entire project on their own. You do get a model or a prototype at the end. Clear technology role. If considered using tools like measuring tools as a use of technology, then yes. Students have to work as a team. Students have to test and or evaluate results, and they communicate their process and how they came up with their final result to the class. So thank you so much for watching. I hope you enjoyed. Looking forward to your feedback.